Hey guys, today I'm going to teach you about transversals. In this image, we have two parallel lines and a transversal that intersects them. The parallel lines are A and B, and the transversal C intersects them. So in this image, if we know one angle, we can figure out all the other angles. So let's say we know this angle right here. We'll call it D. If we know angle D, we can figure out this angle, E. Because this big angle over here is 180 degrees because it's a line. So we can say 180 minus D equals E. We can also figure out angle F because it is opposite to angle D, and opposite angles are equal. So D equals F. Using the same principle, we can figure out angle G. E equals G because they're opposite. So now we figure out all the angles in this intersection. So we don't have to do it the long way. This time, to find all the angles in this intersection, we can use the principle of corresponding angles. So let's call this angle H. E equals H. We know this because they're corresponding. E and H are the same size. We can use this principle again over here with angle I. So F equals I because they're corresponding. We could do that again here with J. G equals J. And over here we have K. And D equals K. So now I'm going to give you an example problem with real angles for you to practice. And afterwards, I'll give you the answer and I'll show you how to figure out the angles, and you can see if you did them right. And if you didn't, then you can figure out how to do it correctly. Okay, so here we have an example problem, and we know one angle, which is 115 degrees, and we know these two lines are parallel with the red symbols to show that they're parallel. So I'm going to give you some time to pause the video and figure out these angles right here. And you can do so because you know this one angle, that's 115 degrees. So feel free to pause the video. Okay, now you've probably unpaused the video and have finished the problem. So I'm going to let you check your work with this while I do the problem with you. So we can figure out all the other angles by knowing 115, as you know. So we can figure out this angle right here because we know that it's opposite from the original angle that we knew, so it's 115 degrees as well because opposite angles are equal. Now we can figure out this angle over here because we know that this big angle is 180 degrees, and 180 minus 115 equals 65. So it's 65 degrees. Then, since it's opposite with this angle, we know that this angle is 65 degrees. And we can use the principle of corresponding angles over here. So we can figure out that this is 65 degrees. And we can figure out that this is also 65 degrees because they're opposite. We know this is 115. And that is 115. So there you have it. That is transversals. So now I'm going to teach you about the three parallels theorem and the midline theorem. So this is the three parallels theorem. So over here we have two transversals, which are the lines that are about to intersect. And we have three parallel lines. And those are the lines that, of course, are parallel and have the same slope. So where these parallel lines intersect the transversals, I have made points. We have A, B, C, D, E, and F. So this theorem states that the parallel lines split up the transversals into proportional parts. So let me show you what I mean by this. We can say that my pen's not working, hold on. We can say that AC over BC is equal to DF over EF, sorry, it's a bad E, okay, over EF. So let me give you another example of this. We can also say that AB over BC is equal to DE over EF. So when is this theorem useful? Let me give you an example of when it can be useful. So this is the three parallels theorem again, but this time instead of having variables, I have numbers. So let's say that, well, okay, I know three segments, three line segments. I know that one of them is 6, and then one is 7, and one is 2. But what if I want to find the one right here, the unknown x? Let me make that red. What if I want to find this? I can use the theorem. So I can say that 6 over x is equal to 7 over 2. So now I have 12 equals 7x. Divide that by 7. Divide that by 7. So 12 over 7 equals x. That's how you find x. Boom. That's the three parallels theorem. The last theorem that I'm going to teach you is the midline theorem. Before you know the midline theorem, you need to know what the midline is. The midline is a segment from the midpoint of a side of a triangle to the midpoint of another side of the same triangle. So I've drawn the midline in red in this picture, and so here's the midline theorem. The midline theorem states that the midline, which I'll write as M, is equal to one half of the base, or you can call it the third side, which is right there. So the midline is equal to half of that, and the midline is also parallel to this base. So here's something that's interesting about the midline. Let me see how I can do this. It's hard for me to show you using this application, but if you move this small triangle right here, this triangle with the, sorry, one second. The triangle with the, here are the vertices of the triangle. This triangle, if you flip it that way, you can make a parallelogram. It can make a parallelogram right there. One second. Whoops. So you can make parallelogram. So that's pretty neat. Okay then, so that's the end of my video. I hope you liked it, and thanks.